Today's notes are solving rational exponent equations. So this is a whole new kind of equation, separate from the other ones. There's more random stuff to pay attention to. Each of the equations have their own little brand of special things that you have to watch out for. Like when you check for extraneous solutions on the rational equations, which are the ones that look like fractions, you had to check denominators weren't zero. When we checked for extraneous solutions on yesterday's radical equations, we had to check for something different. Today we don't really have to check for extraneous solutions, but we do have to be careful about when we use plus or minus, that we're doing it in the right spot. So when you go to prepare for your test, I highly recommend taking some flashcards or something. For each section of your notes, we've had 4 separate notes. Write the name of the section on the note card, and then any little thing that's special about it, put that on your cards, and then you can quiz yourself for it and when you start preparing for your test. And I'll have your test reviews ready for you tomorrow in case you want to work on it over the weekend. This is our last new lesson. Tomorrow's a practice day. Monday is to work on the test review. And your test is Tuesday. This stuff right here looks a little bit crazy. Here's what's going on. I'll give you some concrete examples to clear it up. This is saying basically that if you have something in the u spot, like you have an x, and it's being raised to a power that looks like a fraction, like maybe it's 2/3, and let's say it equals some, I don't know, this is not going to work out nicely, but let's equal 17. Okay, that's the v part. If you're trying to solve for x and get rid of that 2/3 exponent, what you can do is raise both sides to a power. What do you think this power is? What's the relationship between this m over n and this n over m? What's going on there? It's the inverse, right? Or the reciprocal. So that's how you get rid of or undo fraction exponents. You raise both sides to the reciprocal power, because in exponent math, we have this rule called power of a power, which says that these two things get multiplied. Well, what do you get when you multiply 2/3 by 3/2? 1, right? When you multiply reciprocals, they cancel out. So those would be gone, leaving me x here and 17 to the 3/2 here. And this is what we're talking about today, basically, how to do that math when you have a number with a fraction for an exponent. And before we get into the problems, I want to review a few things about this stuff you've seen before, but you need a refresher on. You don't have to write down what I'm about to write down. I recommend you do if you don't remember this stuff. The first thing I want to remind you about is this. Any root, like a square root, can be rewritten with a rational exponent or a fraction exponent. So like, for example, if I had the square root of 4, now what's the root here? We don't ever write it, but the root is actually 2. For square roots, we don't write the 2 because it's so common to have a square root, we just don't bother writing the 2. It's just understood. This is equivalent to this, 4 to the 1/2, right? And we can rewrite any root in radical form. We can rewrite it to a rational exponent, a fraction exponent. If I had the cube root of 8, how could I rewrite that with a fraction for an exponent? What would I write? 8 to the 1/3 plus, okay, and so forth and so on. If that was the only thing we were doing, this lesson wouldn't be so bad. Or it's not bad, sorry. It wouldn't be so, I don't want to be negative. It wouldn't be so bad, hard. I don't know. It's not really bad or hard. Moving on. I overthought that whole thing. So the difference in today's lesson is we won't have just a 1 in the numerator. We might have instead something like this, 8 to the 2/3. And here's what's going on there, okay? You have the root. What root is that? Still what root? Still a cube root, still a third root. But now it has a power of 2, which is like squaring it. And the thing that I want you to remember, or the sort of skill that we're going to work with, is we are going to rewrite that fraction into its two parts, its root part and its power part. And so we'll rewrite it something like this. We'll write the root first by itself, and then the power on the outside. And the reason we would want to do that is it makes our math easier to perform when we take a root first and a power second. And the reason we can do this is, again, the power to a power rule, which says these get multiplied. Well, what is 1/3 times 2? It's 2/3. The same thing that we had here. So we will just be practicing rewriting that fraction exponent into the root part and the power part separate, because it's easier to do the math in those pieces, and because we don't have the yellow calculators to do it for us. One thing I do want you to write down, so maybe you didn't write any of that down, but back up at the top, there's something I absolutely want you to write, and it's right here. The fraction exponents have two parts, the top and the bottom, the numerator and the denominator. The denominator is the root, so it's the square root, the third root, the fourth root. The top, the m, is the power, like squaring it, cubing it, raising it to the fourth power. Okay? And you can do the math on those separately. All right. These words are a bunch of stuff that I'm going to talk about while we work the next problem. Here we have x minus 3 to the 2/3 equals 4. Your first step is to always isolate the variable term, meaning, oh, that's not what I wanted. Meaning, getting it by itself. But this is already isolated because there's nothing being added or subtracted on the outside. There's nothing being multiplied or divided on the outside. So it's already by itself. We don't have to do any pre-work. So we can go straight to the part where we undo the 2/3. And what did I talk about? How are we going to undo the 2/3? We're going to raise it to what power? 3/2, the reciprocal power. So as I do these problems, I'm going to be putting explanations on the left. I highly recommend you jot those down as well. Whatever shorthand you like, so you know what is happening, because you're going to think that you'll remember what we did, probably maybe not going to remember what we did or why. So write down the reasons on the left as you go. And the first thing that I'm going to write down is apply the reciprocal power. And you already said that it's 3/2. And you need to do that to both sides to keep the equation in balance. So what do you think that will leave me on the left-hand side? X minus 3, because the powers are canceling out. And on the right-hand side, I have 4 to the 3/2. And I'm going to write something. I need your eyeballs up here so you can see what I'm going to write, and then I want you to think about why I wrote it. Are you looking right here? Why do you think, and don't holler out, so I want everyone's brains to work. What about that fraction, the 3/2, required me to put in the plus or minus? And raise your hand when you think you know what's going on. Think you know? You think you know? Who feels like they have no idea? Like I just randomly put some stuff up there and you can't figure out why. Here's my question for you. What kind of problems have we done in the past when we had to use plus or minus? We were square roots, right? So I submit for your consideration that I just square rooted both sides. Did I? What part of that is the square root? The 2. Is that what you're going to say? Yeah, the half. The 2 that's on the bottom is a root. And if it's a 2, it's a square root. So we talked a little while ago about how this is the same as this, 4 to the 1/2. Okay? It's just another way of writing the radical. So if at any time, so here's the thing I'm going to need you to write down. If at any time you've raised both sides to a power that has an even root or even denominator, you have to use plus or minus. Now, it doesn't matter the black number had an even. We don't care about that. That's not what's making the choice for us. It's what you're doing to both sides. You raised it to a power with an even denominator. That means a root, so you need plus or minus. So over here, write something like this. Use plus or minus. That's supposed to say when applying an even root to both sides. Root / denominator to both sides. We don't care if the original denominator of the fraction was even, only the one that we're doing to the left and the right as part of our solving. And that is because you're essentially taking a square root of both sides. All right, so here's where we're going to do the thing where we break apart the fraction into 2 pieces. So I'm going to separate the root in power. And then I'm going to simplify and solve. So you want to do the root first because it keeps your math easier. And so the root is what part, the 3 or the 2? Which is the root? The 2. Okay. So I'm going to write it like this. This is the root part. I'm going to put it in parentheses to indicate that I'm doing that first. And then the power will go here on the outside. And again, 4 to the 1/2 means the square root of 4, which is what? 2. So my next step looks like this. X minus 3 equals plus or minus 2 to the 3rd. And 2 to the 3rd means 2 times 2 times 2, which is 8, right? Not 6. So x minus 3 equals plus or minus 8 now. And we add the 3 to both sides. But I don't want to leave my answer here because there's still more math that I can do. And if there is more math to do, you want to do it. This really represents 2 different equations. X equals 3 plus 8 and x equals 3 minus 8. So that's 11 and negative 5. Questions about anything so far on there? All right, we're going to do 2 more examples. So we're going to practice this 2 more times. All right, on this one, it's not isolated yet. So we have to do some of that pre-work to get the variable term all by itself. So here's that. I need it by itself. Right now it has a times 3 on the outside and a minus 9 on the outside. What do I have to take care of first? Add 9, right? So isolate variable term is what we're doing first. By adding 9. Three times x plus 1 to the 3/4 equals 24. And now we divide by 3. So that is a successfully isolated term. Now I need to get rid of the 3/4. So I apply reciprocal power. All day I've been feeling like when I say that, it's some kind of like science thing, like apply reciprocal power or something. I don't know. It's made me feel important all day. So what is the reciprocal power? 4/3. Okay? So both sides to the 4/3. It's kind of smushed, sorry. Smushed. Do I need to do plus or minus here? No, because the root that I just applied to both sides is what kind of number? Even or odd? Odd. Okay. So only when that red root, the red stuff, the red root, red rum. Have y'all seen The Shining? Oh my gosh, it's so creepy. Okay. The Shining is the scariest book I ever read in my whole entire life. There's a new one? No. Is that movie theaters? Like, is that new? Oh no, I don't know. Really? Okay, so we don't need the plus or minus because the root is odd. So we're here now. We now separate the root from the power and simplify. And then simplify and solve. That's a solve. So we want to do the root first. What's the root? Which one, the 4 or the 3? 3, okay. So I'm going to write it with the root first. You can technically do the power first, but it will give you a really big number that you then have to do the root for, and it just makes it harder. And power on the outside. And what is the third root of 8? Yes. The third root of 8 is? What number? 2. Okay, what times itself 3 times is 8? The answer is 2. So 2 to the 4th now. 2 to the 4 is 2 times 2, which is 4, times 2 is 8, times 2 is 16. So x plus 1 equals 16. Subtract the 1. Hooah. X equals 15. And I'm going to set you up a little bit on the next one and then give you a few minutes to finish it out by yourself. What's funky about the next one? The fraction. The bears. 5 9 x to the 5/3 plus 92 gives 1. How do we begin? Subtract 92, right? So we begin by isolating the variable term, which in this case is the x to the 5/3. No parentheses or anything this time. So minus 92 to both sides. 5/9, x to the 5/3 equals negative 135. So let's talk about how to get rid of that 5/9. You can do the reciprocal. So some people like to do it in parts. Multiply 9 by both sides, which is fine. And then divide by 5 to both sides, which is fine. But you can do that in one step by just multiplying by the reciprocal of 5/9. Because what that means is you're multiplying by 9 and then dividing by 5 all in one step. So the 9/5 and the 5/9 cancel each other out, leaving me x to the 5/3. And then on the right, you're essentially multiplying fractions across the top, across the bottom. Do your division, negative 243. And here is where I'm going to let you finish by yourself. So take a moment and do that. I saw y'all on your papers. You applied the reciprocal power. Apply reciprocal power. And the reciprocal of 5/3 is 3/5. So 5/3 and 3/5 cancel, leaving me x. Separating the root from the power is the next part. So negative 243 to the 1/5 raised to the 3. You're trying to find a number that's multiplied by itself 5 times that gives you a negative 243. That's what a fifth root means. And so a lot of people tell me today, oh, I don't know how to do that. Well, actually, you do. You're just resisting. It's a number times itself 5 times. What's the smallest number you could try? Even smaller. You could start with 2, and you really literally just have to go to your baby calculator and multiply it by itself 5 times and see what it gives you. Now 2 doesn't work. And here's some shortcuts. You should know that 2 is not going to work because it ends in a 3. And no matter how many times you multiply 2 by itself, you will never get a number that ends in 3. You always get an even number. You also know 5 won't work, right? Because if it did, it would have to end in a 5. So you start with 3. 3 to the 5th is, guess what? 243. You really just have to trial and error it out in this case. Try 3 times itself 5 times. If that doesn't work, 4 times itself 5 times until you get something that works. And by the way, all the problems that we're giving you on this and the review and your test, they will all work out. So don't worry about if it doesn't. They all will be integers. But it's not just 3. It's a negative 3. And let me tell you why it's not a negative 3i. Okay? Yes, there's a negative number. And yes, we're taking a root. But I is the solution to the square root of negative 1. And the reason why we need I to solve that is because there's no number times itself, right, because that's the square root, that will give you a negative. So we had to come up with something, and we called it I. But that's not the case for odd roots. If I took the cube root of negative 1, I can actually do that math. It is defined. And it's negative 1. Because negative 1 times itself 3 times is still a negative number, right? That's positive 1, and then times that is negative 1. So when you're taking the root of a negative number, and it's an odd root, you're good to go by leaving it negative. You don't have to put an I. I is for even roots only. Okay? And so then we have negative 3 to the positive 3, and that's this. Negative 3 times itself 3 times. What's the sign on that answer going to be? Negative, right? Negative 27. any major